Hello everyone. In the past few videos, I have showed you how you can generate different kinds of fingerprints using various libraries in Python. If you haven't seen that videos, I highly recommend you to go check that out because today's topic of Tanimoto Similarity is largely based on fingerprints. The Tanimoto Similarity, also known as Jaccard Index, is a measure of the similarity between two sets. In the context of cheminformatics and molecular informatics, the Tanimoto similarity is often used to quantify the similarity between two chemical compounds based on their molecular fingerprints. The Tanimoto similarity coefficient is calculating using the following formula. In this, A and B are two sets, and in the language of cheminformatics, the set can have different features or fingerprints representing chemical compounds. The numerator is the size or number of elements of the intersection of sets A and B, and denominator is the size of the union of sets A and B. The Tanimoto coefficient ranges from 0 to 1, where 0 indicates no similarity and completely dissimilar sets, whereas 1 indicates complete similarity or identical sets. Now let me take you to the Google Colab notebook and show you how practically we can calculate Tanimoto similarity. We will start off by installing rdkit, followed by importing various libraries such as pandas and numpy. Along with that, I am gonna be importing various important modules from rdkit which would assist us in calculating fingerprints as well as Tanimoto similarity. So let's go ahead and do that. After we have finished importing libraries, I am reading an Excel file which contains the name and smile strings of 100 alcohol molecules. So let me just read this and have a look at 5 data points. So as you can see, this data set contains name and the corresponding smile strings of these molecules. For generating fingerprints, we need to convert these smile strings into molecular objects or graphs, and we can do that with the help of this command here, pandas tools dot add molecule column to frame, which takes in smile strings from this data frame and makes another column called mole, which would contain the molecular objects of these molecules. So let's run this and have a look at the first 5 data points. Now you can see we have another column called mole which contains the molecular objects, and we can easily visualize these molecules using draw.moles to grid image function of rdkit. Here I am just printing the molecular structure of first 16 molecules. So let's go ahead and do that. Now you can see here these are the molecular structures or graphs of the data set that we are using. Now coming back to Tanimoto similarity, let us just suppose that there are two molecules, benzyl alcohol and phenyl ethanol, for which we want to calculate the Tanimoto coefficient, or we want to see how similar these two molecules are. For that, the first step is generating their fingerprints. So let's go ahead and do that. Here I am printing the molecular structure of these two molecules for which we want to calculate the Tanimoto coefficient. So you can see this is benzyl alcohol and this is 2-phenyl ethanol. Now again, the first step is calculating their fingerprint. I am calculating their Morgan fingerprint. So all we have to do is use this module allchem and use this function on it dot get Morgan fingerprint as bit vector, which takes argument as molecular object. Radius here is 2 and the length of bits I have chosen as 2048. Now this variable here, mf_ba, will store the fingerprints of benzyl alcohol, and mf_pe, it will store the Morgan fingerprint of 2-phenyl ethanol as a bit vector. Now let's run this. Now let me print the position and number of on bits, or the bits where the value is 1. We can easily do that by calling get on bits function on this object here. It will print out the bits position where the value is 1. Also I am using this counter function which will calculate the number of zeros and ones. So let's run this command. So you can see that for benzyl alcohol here, which is our first molecule, the bits are on at these positions, and we have 2034 zeros and 14 ones. So basically we have ones at these 14 positions. Now next I'm gonna be repeating the same process for phenylethanol. For phenylethanol, you can see these are the bit positions where we have ones and the number of ones are 16. Basically, that means the number of elements in this are 16 and we have around 2032 zeros. Now once we have the Morgan fingerprint of these two molecules in hand, we can go ahead and calculate the intersection and union of these two fingerprints. The intersection of two sets, or in this case of two fingerprints for molecules A and B, is the set of elements that are common to both the sets. Whereas the union of two sets A and B is the set of all distinct elements from both these sets. Basically in here the duplicates would be removed and we will include all the unique bit position where the value of fingerprint is 1. Now if you remember, we used .getOnBits function to generate the position of on bits. We are gonna be using the same function on both the bit vector objects of our two molecules, followed by generating sets out of the output, and finally using AND operator, which will provide us the intersection of two sets. So let's run this command. In the output you can see we have the set of elements that are common to both the sets. Now for calculating Tanimoto coefficient we need the length of this set, so I am running a len function on this. Let me do that. So you can see the length or the number of elements in this set are 11. I'm gonna be repeating the same process for generating the union of two sets, except that instead of AND operator I am using an OR operator here. So let's just run this command and see the output. So now you can see that this is a set which does not has any duplicates and it has all the unique bit positions where the value of fingerprint is 1 and the length of this set is 19. Now for calculating Tanimoto coefficient we need just these two numbers 11 and 19. So let's just input the size of two sets in their respective position and calculate Tanimoto coefficient. So you can see here the Tanimoto coefficient is 0.5789. That means these two molecules are 57.89% similar. Now you don't need to do all this manually. There is a Tanimoto similarity function which I have imported above here. So you can see there this Tanimoto similarity function can be imported from rdkit.datastructs.cdatastructs. So let me run this function with input as the bit vector of our first molecule benzyl alcohol and the second argument is the bit vector of our second molecule which is phenylethanol. Now you can see here the value is same as that calculated by us manually, 0.57894. Now in case you want to compare one molecule with a whole data set, for that what you have to do is generate the molecular fingerprint bit vector of all the molecules in the data set. I am doing that using list comprehension command here. So let's go ahead and run this. For calculating Tanimoto similarity coefficient, again I am using this Tanimoto similarity function where the first argument is the query molecule or the molecule which we want to compare with the whole data set. This list comprehension here is like a for loop which will iterate through each molecule and find the Tanimoto similarity coefficient of each molecule with our query molecule which is benzyl alcohol here. Next, for visualizing it more appropriately, I am creating another column called TS_index which would contain the values of Tanimoto similarity index generated by this list comprehension over here. So let me run these commands and see the output. In the output, you can see a data set which contains names, smiles, molecular objects, as well as Tanimoto Similarity Index or coefficient. So this number here basically means that benzyl alcohol is 37.5% similar to this molecule here, which is 2-phenoxyethanol. Similarly, since it is the same molecule, therefore the coefficient is 1 here. This is phenylethanol, which we compared above and had a Tanimoto coefficient of 0.5789. In this manner, you can compare the similarity between two molecules or amongst different molecules in a data set using Tanimoto similarity and different kinds of fingerprints. That is it for now. Thank you for watching.